Question number 1. This question is about first 30 elements in the periodic table. So to answer the following questions, we have to look at element number 1, hydrogen, to element number 30, that is zinc. So let's start. Name the element which is 78% of clean dry air. You all know very well that element is nitrogen. It is clearly mentioned in the syllabus. Next, that has atoms with electronic structure of 2, 8, 1. So add these numbers, 2 plus 8 plus 1, it is element number 11. And look at the periodic table. You will know the element number 11 is sodium. And which element is extracted from hematite? That is, of course, iron. We have studied the process of extraction of iron in detail. And which element forms an oxide with giant covalent structure? Silicon 4 oxide has giant covalent structure, so the name of element would be silicon, cause it forms the giant covalent structure. Next, which is the gas with slowest rate of diffusion at room temperature? So you have to look from hydrogen to zinc, and we will see a gas that has highest MR value, because we know that MR is inversely proportional to the rate of diffusion. So among these first 30 elements, chlorine is the element that is a gas with slowest rate of diffusion. Why? Because it has highest MR value, and the MR value for chlorine molecule is 71. It has anhydrous chloride which turns pink when water is added. So we studied about this chloride in equilibrium and also in chemical tests for water. So definitely this is cobalt chloride because the anhydrous form of cobalt chloride is blue, but when water is added it turns pink. So cobalt is the answer. Has aqueous ion which forms a white precipitate when added to aqueous silver ions. So one of the ions is silver ions, and when it is combining with some negative ion, it forms a white precipitate. We have studied about precipitates of silver with chloride, bromide and iodide, and we know that the precipitate of silver chloride is white. So here this ion should be chloride ion, and that chloride ion is from element chlorine that forms a blue hydroxide which dissolves in aqueous ammonia. So the blue hydroxide is copper 2 hydroxide. So element here is copper. You have to memorize this. And next is which element is added to molten iron to remove impurities in steel making process. So out of these first 30 elements, oxygen is the element that is added to remove impurities. But steel making process is no longer part of syllabus, so you don't have to worry about this. Last one is which is used to galvanize iron. So iron is coated with zinc to protect it from corrosion. Question 2. A student adds excess large pieces of magnesium carbonate to dilute hydrochloric acid and measures the volume of carbon dioxide gas given off. Add the missing state symbols to the chemical equation for the reaction. So first we have magnesium carbonate, that is solid, then HCl, this is aqueous, so I will be writing AQ, and then water is liquid, and carbon dioxide is gas. Complete the dot and cross diagram to show the electron arrangement of ions in magnesium chloride. Magnesium chloride is an ionic compound that has formula MgCl2. Here magnesium has a charge of 2 positive and fluorine has negative charge, and there are 2 chloride ions. So first we have to complete the diagram for magnesium ion. Actually magnesium has 12 electrons, so its electronic structure would be 2, 8 and 2, but when it loses 2 electrons, so one of the shell is lost. Now there should be 2 shells. So here we have the first shell that carries 2 electrons. So you have to draw another shell and it will carry 8 electrons. So 8 cross like this. and after losing these 2 electrons, the charge on magnesium will be 2 positive. On the other hand, chlorine is element number 17. It has 2, 8 and 7 electrons. When it has the negative charge, it means 1 more electron has been added. So there should be 8 electrons in its valence shell now. 2 electrons in the first shell are already there, then 8 electrons in the second shell. So I am drawing another shell, and there should be 7 dots. That are 7 electrons that were already present in the chlorine atom, and 8th electron will be shown by cross, and due to gain of electron it will have negative charge, and we have 2 chloride ions, so same will be the case for the second one. You have to put 7 dots like this and 1 cross and negative charge over here. So this is the complete dot and cross diagram for magnesium chloride. C part of the question says, complete the dot and cross diagram to show the electron arrangement in a molecule of carbon dioxide. Now in this case we have to show outer electrons only. Central atom is carbon. Carbon has 4 electrons in its outermost shell, and it forms 4 covalent bonds. In carbon dioxide, it forms a double covalent bond with 1 oxygen atom and 2 covalent bonds with the other oxygen atom. So all the 4 outer electrons of carbon should be shared. So I am putting a dot over here, over here. These are the 2 electrons of carbon, and these are shared with 2 electrons of oxygen. Similarly, on other side, I am showing the 2 electrons for carbon and these 2 cross for oxygen. Now oxygen has 6 electrons in its outer shell. 2 of the electrons are shared, so there should be 4 more electrons, and you have to show these 4 electrons over the oxygen atom. Similarly, for this oxygen atom, I have to draw the 4 electrons. Okay, that's complete now. Look at the D part. Graph shows how the volume of carbon dioxide gas changes with the time. So you have volume of carbon dioxide on this axis and time on horizontal axis, and you can see that there is a line that is showing the rate of this reaction in terms of how the volume of carbon dioxide gas is changing with time. Now what is the question? Describe how the graph shows that rate of this reaction decreases as the time increases. If you look at the gradient of this graph, you can see that this line is steeper at the beginning, but the gradient decreases as the time increases, and it is becoming flat over time. So you can say that gradient of line decreases as time increases. So the decrease in gradient of line shows that the rate of reaction decreases. Second part, explain in terms of particles why the rate of this reaction decreases as the time increases. When hydrochloric acid starts reacting with magnesium carbonate, the concentration of acid decreases. Concentration of acid decreases with time, and there are lesser collision of particles per unit time. So because there are lesser number of particles, so there will be lesser collisions per unit time. So we can say that the rate of reaction is decreasing. Next, the student repeats the experiment using powdered magnesium carbonate instead of large pieces. All other conditions stays the same. Mean the mass of magnesium carbonate is still same, the temperature is same, the concentration of HCl is same, The only change that he made is he is using powdered magnesium carbonate instead of large pieces. So actually he is increasing the surface area of magnesium carbonate, and we know that the rate of reaction is directly proportional to surface area. So when surface area increases, the rate of the reaction will increase. We have to show this on the grid, and we have to draw the another line. So how can you show the increase in rate of this reaction? So basically you have to draw a new line with gradient increasing. So the gradient of this new line is greater than gradient of the previous one, or you may say that the new line is steeper and it will become flat earlier, but be careful, you don't have to take this line above the previous one, because the volume of carbon dioxide obtained is still same, but it only proceeds with a greater rate. Okay, so you have to make the line more steeper, but you have to end it at the same level that it was ending previously. E part, determine the volume of carbon dioxide gas given off when excess magnesium carbonate is added to 25 centimeter cube of 0.400 mole per decimeter cube HCl at room temperature and pressure. Here is the balanced chemical equation for this reaction, and you have to use the following steps to calculate this. First, calculate the moles of HCl in 25 centimeter cube, that is volume, and 0.400 mole per decimeter cube, that is concentration of acid. And you know moles equals concentration cross volume. Concentration is 0.4 and volume is 25 in centimeter cube. You have to convert this into decimeter cube, so divide this upon 1000. Why are we converting this to decimeter cube? Because we have to cancel the units decimeter cube with decimeter cube, so we will be left with mole. Okay, use your calculator to solve this and you will get 0.01 mole. Now determine the moles of carbon dioxide. For this, look at the equation. The mole ratio for HCl to carbon dioxide is 2:1. It means the moles of carbon dioxide would be half of the moles of HCl. So divide 0.01 by 2 and it will be 0.005 mole. These are the moles for carbon dioxide. Next we have to calculate the volume of carbon dioxide in centimeter cube. The moles of carbon dioxide are 0.005 and multiply this by molar volume, mean the volume for 1 mole of a gas, that is a fixed value 24,000 centimeter cube, and this is at RTP, mean room temperature and pressure. If you multiply this by 0.005, you will be getting 120 centimeter cube. Question number 3. Nitrogen dioxide is an atmospheric pollutant and is formed in car engines. How nitrogen dioxide is formed in car engines? Basically what is happening here, oxygen and nitrogen, both these gases from air are reacted at high temperature in car engines. Oxygen and nitrogen both are present in the air, but they don't react at ordinary conditions. But we know inside the car engines temperature is very high due to combustion reaction, that is exothermic, and as a result they react together and nitrogen dioxide is produced. Nitrogen dioxide causes respiratory problems. State one other adverse effect of nitrogen dioxide. So we are familiar with acid rain, and one of the gas that is responsible for acid rain is nitrogen dioxide. Then nitrogen dioxide emissions can be reduced by adding aqueous solution of urea to car exhaust gases. The heat of the exhaust gases breaks down the urea into simpler substances. Name the type of reaction When a substance is heated and breaks down into simpler substances, such a reaction is called as decomposition. When a substance breaks into simpler substances. One molecule of urea breaks down to form one molecule of ammonia and other molecule. Complete the equation to show the formula of other molecule formed in this reaction. Now, one of the products is ammonia. If you look at the nitrogen atoms in urea, we have 2 nitrogen atoms. So one is there in ammonia. We have left with 1 nitrogen atom. There are 4 hydrogen atoms in urea. 3 are in ammonia. So there should be 1 more hydrogen atom, and then carbon and oxygen are left. So most probably, but certainly, it is HCNO, hydrogen cyanate. State the test for ammonia. Ammonia is a base, and we can use a damp red litmus paper. So the test is to use damp red litmus, and ammonia turns this litmus blue. Because we know that alkaline solution turns damp red litmus blue. D part, the ammonia formed reacts with nitrogen dioxide to form nitrogen and water. Balance the equation for this reaction. So one of the coefficients is given here, that is 12 for water. So first I will balance oxygen, 12 being multiplied with O. So here there are 2 oxygen atoms. You have to multiply this by 6. Then balance hydrogen, 12 cross 2. There are 24 hydrogen atoms on a product side. So multiply this 3 by 8 to get 24. Now it's nitrogen's turn. 8 nitrogen atoms in ammonia, 6 in NO2, 6 plus 8, 14. Multiply N2 by 7 to get total of 14. Now this equation is balanced. State how the equation shows that nitrogen in nitrogen dioxide is reduced. If you look at the nitrogen of nitrogen dioxide, it is being converted into N2. So basically it is losing oxygen. So as this nitrogen loses oxygen, and loss of oxygen is a reduction. So this is how you show that nitrogen is undergoing reduction. This reaction is a redox reaction. State the meaning of term redox. Redox means a reduction and oxidation. A reaction where oxidation and reduction are taking place is called as a redox reaction. 135 moles of urea, and you have to calculate the mass of urea. Mass equals moles, that are 135 in this case, cross mr, and mr for urea is 60. You can calculate this by adding the AR values for all of the atoms that are involved here. Now if I multiply it by 60, I will get 8100 gram, but I need answer in kilogram. So for this purpose, I have to divide it upon 1000. So it will be equal to 8100 upon 1000 kilogram, and that is 8.1. Another oxide of nitrogen formed in car engines is nitrogen monoxide. A catalytic converter removes NO by reacting it with a gas formed by incomplete combustion of fuel. 2 non-toxic gases are formed. When there is incomplete combustion of fuel, carbon monoxide is produced. So the first answer will be carbon monoxide, and that gas is used to reduce nitrogen monoxide to nitrogen. The reaction that is taking place here is NO plus CO. It produces carbon dioxide. CO is reducing NO and is itself being oxidized. On the other hand, NO is reduced to nitrogen. So basically, the gas that is produced by incomplete combustion is carbon monoxide, and the 2 non-toxic gases that are formed here are carbon dioxide. Okay, and second is nitrogen gas. Question 4. This question is about chemical reactions and electricity. The diagram shows the apparatus used in production of electrical energy in a simple cell. So here is a simple cell that has zinc electrode on one side and iron electrode on other side. There is a voltmeter, and of course there is electrolyte. Zinc electrode dissolves in electrolyte, forming zinc 2 positive ions. It means the zinc is losing electrons as it carries 2 positive charge, so it will lose 2 electrons. Now what is the question? Draw an arrow on the diagram to show the direction of electron flow. So the electron will flow from zinc towards iron. So this is an arrow indicating the flow of electrons. Then write the ionic half equation for the reaction that occurs when zinc electrode dissolves. So basically this is the ionic half equation. I am writing it again. Zinc metal is dissolved. It produces zinc ions and 2 electrons. Now you can say that this is aqueous and it was solid. B part, the reading on voltmeter can be increased if either zinc or iron is replaced by another metal. Name a metal that can replace zinc and increase reading on the voltmeter. So greater is the difference in the reactivity of the two metals, greater will be the reading on the voltmeter. So if one of the metals is iron, and now if you replace zinc by any metal that is above zinc in the reactivity series, it will cause increase in the reading on voltmeter. So let's say you may use magnesium in place of zinc. Similarly, name a metal that can replace iron and increase the reading on voltmeter. Now this time you are keeping zinc there, but on the other hand you have to take any other metal. That metal should be below iron, cause in this way the reactivity difference between the zinc and that metal will get increased and you will get more reading on the voltmeter. So let's say copper, because copper is below zinc in the reactivity series. Next part, fuel cells are used to generate electricity. Name the reactants in a fuel cell. In a fuel cell, hydrogen and oxygen are reacted together to produce water and electricity. So reactants are hydrogen and oxygen. These are the reactants. Name the waste product of the fuel cell. The waste product of fuel cell is water, because the major product of fuel cell is electricity and we get water as a byproduct. Electricity can be used to break down aqueous or molten ionic compounds. Name the process which uses electricity to break aqueous or molten ionic compounds. The process is electrolysis. Explain why the ionic compound needs to be aqueous or molten. If ionic compound is solid, the ions are not free to move, so they do not conduct electricity. But if the ionic compound is in aqueous form or molten, then ions are free to move, so they conduct electricity. Brine is concentrated aqueous sodium chloride. Name 3 substances which are manufactured by passing electricity through brine. When electricity is passed through concentrated aqueous sodium chloride, we get hydrogen at negative electrode, while chlorine gas at the positive electrode. Moreover, the sodium ion and hydroxide ions in the solution are combined together to produce sodium hydroxide. We have studied this in detail in chapter number 4, electrochemistry. Name a different substance formed when molten sodium chloride is used instead of concentrated aqueous sodium chloride. When molten sodium chloride is electrolyzed, we get sodium metal and chlorine gas. So chlorine gas was already being produced, so the product that is different is sodium, because in case of electrolysis of brine we got hydrogen, and now in this case sodium is obtained here. Question 5. This question is about alkanes and alkenes. A part, short chain alkanes and alkenes can be formed from long chain alkanes in a chemical reaction. Name the type of chemical reaction which form short chain alkanes and alkenes from long chain alkanes, that is cracking. Part 2, decane has 10 carbon atoms. It forms ethane and ethene as the only products in this chemical reaction. Write the chemical equation for this reaction. Reactant for this chemical reaction is decane. It has formula C10H22 and it produces ethane C2H6 and ethene C2H4. These are the only products. There is no other product. Now balance this. Multiply C2H6 by 4 and yes, this equation is balanced now. B part, ethane reacts with chlorine at room temperature to form chloroethane and one other product. Name the other product formed. This is substitution reaction of ethane, and in this reaction hydrogen chloride is produced other than chloroethane. So answer here is hydrogen chloride. State the condition needed for this reaction to take place. For this reaction to take place, ultraviolet light is needed, and then ethene reacts with chlorine at room temperature to form dichloroethane. State why this is an addition reaction. This is an addition reaction because only one product is formed. Both the reactants have been added together to give a single product. The chemical equation for this reaction can be represented as shown. The energy change for reaction is -180. Use bond energies to calculate the bond energy of carbon to chlorine bond in kilojoule per mole. So here is a table showing bond energies. Use the following steps. Calculate the energy needed to break bonds. Okay. So there are 4 carbon to hydrogen bonds, and the bond energy for one CH bond is 410. Multiply this by 4. Then there is carbon to carbon double bond. The bond energy for this is 610. And is there any other bond on the reactant side? Yes, there is chlorine to chlorine bond, and the energy for this bond is 240. Add this using calculator. The answer is 2490 kilojoule. So 2490. Step 2. Use your answer in step 1 and energy change for reaction to determine the energy released when bonds are formed. So energy absorbed minus energy released, it equals -180 kilojoule. This is given in the question. So energy absorbed is 2490 and we have to calculate the energy released. Rearrange this. Energy released will be equal to 2490 plus 180, and that equals 2670 kilojoule. Step 3. Use your answer in step 2 and bond energy values to determine the energy of carbon to chlorine bond. Now we have calculated the energy released, that is 2670. This is for all the bonds that are formed on the products side. Now look at the product. There is only a single product. There are 4 carbon to hydrogen bonds, 2 carbon to chlorine bonds, and there is 1 carbon to carbon bond. So for 4 carbon to hydrogen bonds, 410, multiply it by 4. For 1 carbon to carbon bond, the energy is 350, and there are 2 carbon to chlorine bonds. We have no idea about the energy for this bond, and the sum of this all should be equal to 2670. That is the energy released in this reaction. Now solve this. This equals 1990. So 2 carbon to chlorine is equal to 2670 minus 1990, and that equals 680 kilojoule per mole. This is for 2 carbon to chlorine bonds. We want energy for a single carbon to chlorine bond, so here 2 Divide this upon 680, 680 upon 2, and the final answer will be 340 kilojoule per mole. Question 6. The names of 4 esters are listed: methyl propanoate, ethyl propanoate, propyl propanoate, and butyl propanoate. Esters are family of organic compounds with similar chemical properties. They can be represented by formula CnH2nO2. State the name given to family of organic compounds with similar chemical properties that is called as homologous series. Explain why the members of family of organic compounds have similar chemical properties. They have similar chemical properties because all the members from same family have same functional group. They have same functional group. State name given to formula such as such type of formula is called as general formula for a class. Determine the value of N in butyl propanoate. N shows the number of carbon atoms. Butyl part has 4 carbon atoms while the propanoate part has 3. So the number of carbon is 7. All 4 of the esters are liquids at room temperature. Name the technique used to separate ethyl propanoate from mixture of 4 esters. The technique that is used to separate liquids from mixture is fractional distillation, in which different liquids are separated on the basis of difference in their boiling point. So technique used here is fractional distillation. All the 4 esters can be made by reacting different alcohols with the same substance. Name this substance and draw its structure. Basically, esters are formed by reaction of alcohol and carboxylic acid. So we are using different alcohols, but carboxylic acid is same. If you look at the names of all these 4 esters, there comes propanoate, 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 propanoate. It means the carboxylic acid that is reacting with alcohol is propanoic acid. So the name of acid is propanoic acid, and the structure for propanoic acid is CH3. You have to show all the bonds, then CH2, carbon double bond oxygen, then oxygen, and single bond hydrogen. This is the structure for propanoic acid. Name the alcohol used to make methyl propanoate. The word methyl indicates that alcohol used is methanol. Other esters not in the list have same molecular formula as propyl propanoate. State the term used to describe the substance. Same molecular formula but different structures. Such substances are called as structural isomers. Name 2 esters with same molecular formula as propyl propanoate. Propyl propanoate has 3 plus 3 equal 6 carbon atoms. So you have to name any other 2 esters that have 6 carbon atoms. So one could be ethyl butanoate. Alcohol has 2 carbon atoms, and carboxylic acid that is forming this ester has 4 carbon atoms. So you may also say that methyl pentanoate. In this ester, alcohol part has 1 carbon atom and carboxylic acid part has 5 carbon atoms. So again there are 6 carbon atoms. So these 2 are the structural isomers of propyl propanoate because they would have same molecular formula as propyl propanoate. Polyesters can be made from 2 different molecules shown. So here are the 2 molecules that form the polyester. Complete the diagram to show section of polyester formed from these 2 molecules. Include all of the atoms and all of the bonds in the linkages. So in this reaction, OH group is removed from carboxylic acid and H is removed from alcohol. So where there is white box, you have to show oxygen atoms on both sides like this, and this gray box will be having carbon double bond oxygen on both sides, and repeat this pattern again. This white box is carrying oxygen on both sides, and this box is carrying C double bond O and C double bond O, and the pattern will be continuing. This is the structure, and it has this ester linkage. So you have to show the ester linkages, and these ester linkages should be shown in the correct order. Name the type of polymerization that takes place when this polymer forms. As this polymer is formed with release of a small molecule, that is water in this case, such type of polymerization is called as condensation polymerization. Last part, name a polyester. One of the polyesters that are mentioned in the syllabus is terylene. It is a common polyester.